Hey there, in this video we're giving an introduction to arrays in C++ programming, and this covers section 7.1 to 7.3 in the Gaddis textbook or thereabouts. Now previously in chapter 6 we were starting to think about how do you handle larger programs, and the story of chapter 6 is how do you deal with growing amounts of code, very large code files. And the solution at that point was to split the code file up into very small sections that we call functions, and then you can just focus on one small thing at a time. Now, chapter 7 here is the other side of the story of how do you handle growing amounts of data. What happens if your program needs like 1,000 variables to store all the data that it needs? And what we'll see here is that there's a very simple technique. It just takes one line of code. It's so simple, called an array, where you can very quickly make 1,000 variables at once if you need. But then how you handle that later on gets very interesting. So a really critical part of any programming language is this idea of arrays. It is the most basic way that you can very easily handle a whole lot of data. All right, so here's the basic idea. An array is going to be a sequence of some single data type. It's going to be 1,000 integers, or it's going to be 1,000 characters, or whatever you need. And the basic idea we're taking from mathematics writing of variables with subscripts. So hopefully you've seen this previously in a math class. At some point, you start needing so many variables that you run out of letters in the alphabet. So what we start doing is tagging or subscripting particular letters with a number to indicate which variable it is. So in a math class, you'd usually write something like this. You'd have x subscript 0, x subscript 1, x subscript 2. Or for short, people usually pronounce that x sub naught, x sub 1, x sub 2, x sub 3, and so forth. So the nice thing there is now that you've got a number in the mix for that subscript or index, some people call it, you can have as many variables as you want. All you need to do is just count that subscript up to whatever level you need. So we're going to take that exact same idea. We would love to be able to write that exact same thing in our programming language. Now, obviously, you can't literally make that little subscript number on the keyboard, so we'll need another way of indicating that, but that's exactly what we want to do for an arbitrarily large number of variables. So when you make an array in C++ or any other programming language, it's all going to be a whole bunch of values of the same type. So it's going to be a whole bunch of integers, or it's going to be a whole bunch of characters, or it could be a whole bunch of strings, but you can't mix and match different types in the same array. Having done that, again, with just one line of code that we're going to see in the next slide, you can have any number of items you want up to the limits of your memory. So for example, if my system here has 8 gigabytes of memory, that's 8 billion bytes, and I know that an integer here takes up 4 bytes, then I ought to be able to make an array maybe as large as 2 billion integers. And really the only limit is just how much memory I have in my system. So you can make very large arrays very easily here. Now, the data in your array is literally just stored in one single contiguous block. So if you think back to the very first lecture in this series where we're talking about memory addressing, memory has a whole bunch of bytes, they're laid out, they have an address about where they are. When you make an array, you're making one single connected block of stuff. There's no gaps, it's not separated out in memory, it's just one single block of adjacent memory locations from start to finish. Now, later on in programming, you might learn some other techniques that allow you to separate stuff out in memory in different ways, but we'll leave that for another course probably. Using arrays, just one single connected block, is the simplest possible thing that any programming language can do as far as getting a large amount of data. So very simple, frankly. And then once you do that, the individual elements are going to be identified by an integer index or subscript, I'll probably call it, just like that 0, 1, 2 up there on the x's. So you can indicate which of these variables you want to use at a particular time with these integer indices. And just like you have up here, we start counting with 0. And we've seen that before. That's the common thing to do in computer science. It makes a lot of sense for arrays just like everything else. So the very first thing is going to be subscript number 0. Here's a little example of that. So let's say that I made an array of integers, and every block here indicates one integer, and the size of this array is 5. I made 5 integers here. And you can see that the way the subscripting, the indexing works, the very first one is index 0, and then there's index 1, 2, 3, and 4 is the last one. So if I have a size 5 array, the very last index is 4. And that's always going to be the case. So whatever the size of your array is, the indices go from 0 to 1 less than the size. Sometimes for beginning programmers, that's easy to trip up over, but it's really important that you get accustomed to that and realize that in a size 5 array, there is no element subscript 5. Okay, so hopefully this sounds promising, that it's going to be very easy to make a very large block of data, a very large number of variables. Let's see how we're going to do that. So this right here is what it looks like when you declare an array. Just like that. That's it, right? So arrays are indicated by square brackets. We can't actually type the little subscript numbers that we would really like to do. So what we're going to do is we're going to indicate the subscripts in these square brackets. That's how we indicate that in C++ or related languages. So what's happening here is basically it looks a lot like you're declaring a variable, because you are, frankly. This first thing here is a type. So it's going to be int, char, float, bool, string, something like that, of what kind of things you want to store in this array. Give it a good name, right? It should be descriptive, clearly describing what kind of thing you're storing here. And there's square brackets, and the size that you want the array to be, you put that in the square brackets. That size has to be an integer above 0. It doesn't make sense for that to be negative. It doesn't make sense to make an array of size 0. It doesn't make sense to use a float, like you can't have 2.5 things in an array. It's got to be an integer there. And quite frequently we're going to see, probably all the examples you see, we're going to make a named constant to store the size, because we're going to need to keep referring back to that in a whole lot of code later on that makes use of the array. So we might do something like make a constant integer called size and set it to 100 if I want a 100 element array. That's very, very common, and you should expect to see that pretty much all the time. Now, one important point at the bottom of this slide here is in standard C or C++, that size in the array declaration must be a constant. It's required to be a constant in International Standards Organization C++. And I see a common mistake for beginning programmers is they want to put a variable in the square brackets of the array declaration. And actually, some compilers permit that, but others don't. So I would highly recommend not getting in the habit of putting a variable there, because over time, that's been found to be a security risk, actually. There's actually there's problems in memory if you do that. So make sure you're putting a literal number, or even better, a named constant for the size of your arrays. All right, so at this point, you've made an array. You've got a big block of memory in the system that's really a whole bunch of separate variables. How are you actually going to use all those different variables? It's going to look like this. When you want to access one of the variables, you put down the name of the array, square brackets, and now this can actually be a variable if you want. The index or the subscript of which of the variables you want. So elements are accessed by these square brackets after the array name with an integer index. And when you do that, now you're referring to one of these several variables, and you can do whatever you want with it. You can sin it, you can count it, you can use it in math, you can assign it, you can pass it to a function, right? Just anything you do with a normal variable, here is one of the variables with the appropriate number. Now, a couple of details about what's actually happening here that might be important later on. That when you make an array, the actual name of the array all by itself is actually holding the address of where the array starts in memory. Again, you think back to memory addressing from day one. The name of the array is actually holding an address of where the array starts. And when you write down this syntax, when you write down name of the array, which is what I was just talking about, and then square brackets with some kind of index, what the computer is actually going to do is it's going to add those numbers, which basically winds up stepping further into the memory addresses to the location that you actually want for your single variable. So there's actually an addition happening between the address where the name is and the index, so you go that many more steps into the array for your particular variable, is what's actually happening there kind of under the hood. But again, most of the time you don't have to think about that. You're going to put down name of the array, square brackets, a subscript you want, and that's just another variable. Do whatever you want with it. So here is the first example program in chapter 7. And this program asks for the number of hours worked by 6 employees. And it's going to store the values in an array. So presumably have kind of a small company here with just 6 employees. How are you going to record all of their hours worked in a particular week? So here we get into the main function. And as usual, you're going to declare your data to begin with. And just like we said, we have a named constant to store the size of the array here. So here's a constant integer called num_employees, which of course is short for number of employees. And it's clear and it's descriptive and everybody can understand what that means. And it's being set to 6. And then here on line 9 is really the important thing. This is all the data in the entire program. We're making an array, and you can tell that from the square brackets. This array holds a bunch of integers. The name of the array is hours. And of course, the size of the array is num_employees or 6. So on line 9, you just made 6 integers, one after the other in one single block in memory. Now let's actually start using them. So you get into the user input part of the program, and we prompt the user to enter the hours worked by 6 employees. And you can see you get to line 14, and the user is going to send in a number, and it's going to get stored in hours sub 0. So the very first integer in that array, hours sub 0, that receives the first piece of input. And then line 15 happens, and the user types something in, and that gets stored in the variable hours sub 1. And you keep going through like that, kind of repetitively, and you store something in hours sub 2, and hours sub 3, and hours sub 4, and hours sub 5. Remember, for a 6-element array, the first element is subscript 0, and the last one's going to be 5. So that actually does put data in all 6 integers in the array. 1, 2, 3, 4, 5, 6. Yeah, that makes sense. Okay, and then here comes the output part of this program, which is going to print all those numbers back out again. And you get a label, the hours that you entered are, and you count out like a space so things aren't being smashed up in the interface. You count out hours sub 0, and then hours sub 1, and hours sub 2, and hours sub 3, and so on like that. So you can see that with the 6 variables, it's very, very easy and very consistent in how you're going to access those different variables. Is here's the name of the array hours, right? Square brackets, and here's the subscript of which one I actually want to access right now. Use it in a sin, use it in a count, use it in some math, assign to it. They're just a bunch of variables. Okay, so here is this program 7.1 in the IDE. This program that asks for the number of hours worked by 6 employees using an array to store it all. And I think that, the very first time we ever see an array, I think I actually want to look at this in the debugger so we can see live what's actually happening in memory with our array. So I'll put a breakpoint on the very first line of the program, and I'll compile it. Great. And I'll start debugging it. So as we've seen before, the program's actually running, but we've paused it on the very first line 8. So we can kind of see what happens one line at a time. And over in the debug tab, I want to keep an eye on what's happening in memory. So I'm going to add a watch. And the important thing, obviously, here is the array hours. So let's see what the debugger shows us for this hours array. Okay. So usually the contents of an array are represented by values in curly braces, separated by commas, and you can see that here. And there are actually 6 integers here. 1, 2, 3, 4, 5, 6. Now remember, when programs start up, the variables, including arrays, if they weren't initialized, are holding a bunch of random garbage, and you can totally see that. Some of these numbers are big, some of these numbers are 0, some of these numbers are even larger than that. But not too surprising, we've got a bunch of random garbage in there. Don't use those numbers in calculations. Don't print them out. They could have been anything, and obviously that's not going to do you any good. So let's see what happens as we start stepping through the program. Here comes the prompt to the user. Enter the hours worked by 6 employees, of course. And here we are on line 14, about to have a sin statement. And I'm going to put in some hours worked by employees. 10, 20, 50. And, keep in mind what I'm doing here is, back in chapter 3, we talked about the keyboard buffer. If the user types in more data than the current sin statement can use, it's going to sit in the keyboard buffer, and then when later SYN statements happen, they'll just pull the data out of the keyboard buffer, and the user doesn't have to type anything in the future. So I'm kind of using that to my advantage here and just typing everything all at once. So some other hours per week someone might work, and maybe 25. Okay, so you can see that based on line 14 here, that took the first number that I typed in, right up to the first space, the 10, and put it in hours sub 0, which is the first thing in the array. Great, that's exactly what we wanted. And then line 15 is going to happen, and it's going to pull out the next thing, which is the 20, and put it into hours sub 1, which will be the second thing in the array. So just keep an eye on this right here, currently a 0, but 1 second later, it's going to be the 20 that I typed in. Okay, and we go through these separate SYN statements. So now the next piece of information goes into hours sub 2, which is this 50. Okay, and then we're going to pull out the 30 that I typed and put it in hours sub 3. So it's going to replace this 58 right here. There's my 30. Okay, and then here comes the 40, and here comes the 25 that I typed in. Okay, so that's exactly what we wanted. So there's the 6 things that I typed in, now being stored in memory in the 6 different locations in the array. Right, hours sub 0 for the first one and hours sub 5 for the last one. And now here's the printing part, and obviously it prints out the label the hours you entered are. And line 23 here, the very first thing it's going to do is print out hours sub 0, right, which is actually the first thing in the array, which will be the number 10. So it goes and looks all that up and prints out the 10. There it is, right, with some spaces. Then we'll go print out hours sub 1, which is this 20. And that gets in the console over there. And it goes on like that. So here comes the next one. Here comes the 30 and the 40 and the 25. And that's everything in the array. So that actually does work to make a single block of memory. Right? You got 6 integers, one after the other in memory. And you can totally access them with these subscripts in square brackets. And that's what an array is. So I think that's a good look at that for the first time. Now, obviously, you're returning out of this function, does some cleanup work, and the program is over. But keep in mind, that's not how programs normally run, just one line at a time like that. So I'm just going to run this once at full speed, so to speak. And what the program normally looks like is this. Okay, enter hours worked by 6 employees, 10, 20, 50, 30, 40, 25. Okay, hit enter. And it appears like they just all reappear on the screen. But that's really all these separate statements, right? One SYN, second, third, fourth, fifth, one after the other, right? Storing in memory. And then these 1, 2, 3, 4, 5, 6 counting statements. And it's just that our processor is running so fast, it can do 4 billion operations per second. It's running so fast, it looks like it's all instantaneous. Not really, but just so fast a human being can't tell the difference. And that's really nice that our arrays and our for loops are so efficient as that. You can get a lot of work done very quickly. Okay, so it's nice that we have arrays, and it's really easy to make a whole lot of data when we need it, but I'm not happy with that prior example because of how repetitive it was, of course. We had a whole lot of lines that were very, very similar and more or less doing the same thing over and over again. Now remember, the main principle in computer science, as far as I'm concerned, from like day 2 in this course, is don't repeat yourself. Don't repeat yourself. The whole point to computers is to do repetitive tasks so that human beings don't have to do them anymore. And if there was a program that was writing down SYN hours 0, SYN hours 1, SYN hours 2, they really ought to step back and think there really ought to be a better way. And of course, the better way to do repetitive tasks is to use a loop from chapter 5, of course. And so fortunately, arrays and loops work super well together. They're totally made to go together. So yeah, the efficient way to step through an array, whether you're doing input or output or something else, is to use a loop. Now, usually we're going to use a for loop because you're going to know the size of the array in advance and you're going to have stored it in a named constant. So that'll be very convenient. Remember, for loops are specialized for count controlled loops when you know in advance how many things you're dealing with. If you didn't know how many things you had, then you have to use a while loop. But for arrays, you're going to know what their size is, so you'll usually use a for loop for that, and it will be very nice. And then you'll have a loop counter, obviously, counting 0, 1, 2, 3, 4, 5, 6, whatever. And that counter will be used in the square brackets as the subscript of which thing you're accessing on each iteration. So the arrays and loops work perfectly fine together, and this will be super convenient. So let's see that. Here's program 7.2, and it's actually doing the exact same job as program 7.1, but notice that it's actually gotten a little bit shorter because we're using loops to remove the repetitive coding. Again, this program is going to ask for the number of hours worked by 6 employees, and it's going to store the values in the exact same kind of array as the last one. So just like last time, make a named constant for the number of employees, which is 6. Here on line 9, you're declaring the array. Again, it's an integer array. It's called hours. Its size is num employees, which is 6. Okay, and you can see further down we have a bunch of for loops in each part of the program. So we're going to need an integer counter for that, and that's being declared on line 10. So here's our count that we'll use in the for loops. And then you get to line 12. Here's the input part of this program. And we do, in fact, have a for loop where the count is going to start at 0, and it's going to go 0, 1, 2, 3, 4, 5, and stop as long as it's less than the number of employees, right? You can't let the count go to the same size as the array because, as we discussed, that's not actually an element in the array. You have to count as long as it's less than the number of employees. And you get into the body of the loop here each time, and it prints out, prompts the user, enter the hours worked by employee count plus 1, and then a colon. Now we'll just think about that for a second. So as programmers, you and I know that the array really starts counting at 0. It goes 0, 1, 2, 3, 4, 5. But for normal users in the real world, so to speak, that would be really weird. They expect things to be counting starting at 1. So we're making things nice for our users by presenting in the interface when count's actually 0, this is going to say enter the hours worked by employee count plus 1, of course, would be 1. And then one step after that, when count is 1, it's going to say enter the hours worked by employee number 2. So even though we know the subscript's really 0 through 5, the end user is going to see 1, 2, 3, 4, 5, 6, and it's going to be a lot easier for them to mentally digest that. So I kind of like that little trick on line 16. We'll probably do that all the time. But the more important thing here is on line 17, we're actually getting the input from the user. So here comes the sin statement, and you're saving whatever they type in on the keyboard into the variable hours subscript, whatever the count is. So the first iteration, you save it in hours sub 0. And the next time, you're going to save it in hours sub 1, and then hours sub 2 and hours sub 3, because that's what's happening with the count variable. So you're doing the exact same work as the prior program, but less programming to do it. The computer takes care of the changing subscript. Awesome. And then you get down to the output part of this program. We're just going to display everything back out. Print out the hours you entered are, and here's another for loop, which is what you do with arrays. Again, the count starts at 0. It keeps going as long as it's less than num employees. And once again, here's the body of the loop on line 23. The first time through, you print out hours sub 0. And then count gets incremented. And the next time through, you print out hours sub 1. And then hours sub 2 and hours sub 3 and all the different variables in the hours array. That's exactly like that. So this is what you do really all the time with arrays. If you're processing an array, if you're inputting to it, if you're printing it out, whatever, you're almost surely going to process it with a for loop, just like this, and you should get very comfortable with that. And here is program 7.2 in the IDE, really our preferred, the better version of the employee hours records program. And so once again, I think I want to start by doing this in debugger, just one line at a time, so we can, very clearly understand what's happening. Here's where I'll pause it, compile this program. Great. Start debugging it with a little purple check mark up there. So let's see if I can get all this stuff on screen at once. All right. I'll put some watches up so we can see what's happening in memory, starting with the array, which is hours. Great. And once again, you can see I have a 6-element array. 1, 2, 3, 4, 5, 6. Bunch of random garbage to begin with. That array is not being initialized immediately. So some large numbers, some zeros, right? No telling what would be up there. But I do have 6 places to use now. There's also this count variable that's going to control the for loop, so I want to keep an eye on that. Also random garbage to begin with. Hopefully we're accustomed to seeing that at this point. Let's actually start processing this and see what happens. Okay, so here on line 13, here's the start of the for loop, and obviously the initializer is going to make count be 0 to begin with, like it ought to be. There we go. And we're going to the body of the loop. So here's where we're going to print out, enter the hours worked by employee number, right? And this is going to be 1 here. Enter the hours worked by employee 1, a little colon. Maybe that'd be better if I made this window a little bit larger. Great. Okay, so remember there's that little trick there with the +1. So the count's actually 0, but the end user's seeing a number 1, which is probably going to feel better in their non-programmer brain, frankly. Now here comes a sin statement here. So the program pauses, waiting for the user to type something in, and I'll type in 10, and this number is going to get stored in hours sub, now count is 0, so hours sub 0, which will be the very first location in the array. So that's where the 10 is going to go right there. Let's see that happen. I guess I have to hit enter here. There we go. Right? So the 10 went here, went back to the for loop, incremented the count. So you can see now count is 1. We're going to go through the body a second time here, obviously. So we're printing out enter the hours worked by employee, and obviously counts 1, so we're about to see a 2 there. There it is. Okay, here comes the next sin statement. So here I'll type in the number 20. And in this case, that number is going to get sent to hours sub, see count is 1 there, hours sub 1, which is actually the second thing. So when I hit enter here, this 65535 number is going to get replaced by the 20. There it is. Right, that right there is hours sub 1. So you're back on the for line. The increment happens, right? The update right there is about to happen. So that's going to make count turn into 2, obviously. There we are, count is 2. And you go on like that. So you see enter the hours worked by employee 3. And here comes this statement here. And I'll type in my 50. And that's going to go into hours sub 2, which will be right there. Okay, so hope you can see the pattern here that's happening with this for loop, processing our array for input. I don't think I need to repeat that every single time. So what I'm going to do is I'm going to make this going to go full speed, but I'll pause it again when we get down to the output part. So I'll just hit continue and then do this full speed for a little bit. So enter hours worked by employee 4, maybe that's 40, right? And this person is 30, right? And so to the end user, we're saying enter the hours worked by employee 6, which we know is really subscript 5, but I'll put in 25 for that. And the program is paused again, and you can see all my data is being stored in the array, like it should be. Awesome. And now the output part is going to print all that stuff out. So here's the label. The hours you entered are, and starting this new for loop, count is going to get reset to 0. There it is right there. And now what are we going to print out in this iteration? We're going to print out a space and then hours sub 0, which is the 10. And there it is, right? And now here's that increment again, right there. So count is about to become 1. You can see that right there. Count is 1 now. And so this time on line 23, we're going to print out hours sub 1, which is the 20. And there's that. And you go through that for loop, and you're going to access every single one of these things in this array as the count goes up by 1 each time. So there's the 50 and the 40 and the 30 and the 25. And now count at this point has actually become, when the next increment happens, it's going to hit 6. And so when it checks in, is count less than num employees? Is 6 less than 6? That's false, and that is what gets you out of the for loop down on line 24. And one more little end line gets printed there, like I like to do myself when you're doing printing, and that's the end of the program. And you have actually recorded and printed out all that data. Awesome. So hopefully that's illustrative of what's actually happening with these for loops. But once again, I just want to do this full speed because that's not what programs normally look like, right? Normally this program would look like this, not waiting for each single step. So ask the user, please enter hours. So here's 10, 20, 50, 40, 30, and 25. And again, when I hit enter, it's going to look like all these numbers show back up instantaneously, but it is actually going through the output for loop for subscript 0 and 1 and 2 and 3 and 4 and 5, one after the other, just super fast. And there they are. Okay, so the human being looks instantaneous, but it's really a whole bunch of separate steps happening on the CPU very, very quickly. And that's what programs normally look like. Now, let's look at this program and think about, initially this is for a little company with only 6 employees. What would have to happen in this program if the company grew and we had 60 employees? Or what if it got really big and we had 600 employees? What would the programmer need to do to modify this program to handle 600 employees? Do you know? Maybe pause the video just for a second. Think about it. Hopefully it's obvious. The only thing you need to change is up on line 8. Just change this number. That's it. So where I have a 6 right now, just make that a 600. And the nice thing, the really smart way that this program was set up with the named constant num employees is if that's 600, then that change flows through to every place where that gets referenced. So now the array on line 9 will be size 600, and the input for loop will happen 600 times, and the output for loop will happen 600 times, and all the other parts of the program just handle that automatically. So very, very smart to use a named constant there, because if you do need to change this on a different day, you only need to change it in one place, not a whole bunch of places. And that's among the reasons we use named constants like that. A, to handle changes, and B, just to make it very readable for other programmers. Generally speaking, we like good names, legible names, instead of like cryptic numbers in a bunch of places. Let me just very quickly confirm that so I can compile this. Compiles fine, and then I can start running it. And now I've got an array of size 600. So obviously that would take a lot of data to fill in. Obviously that's not really a legitimate number of hours worked, but I'm just putting in some kind of data. And you can see that obviously the array is larger than it used to be, right? We only used to have 6. And if I was going to fill out the entirety of that array, I'd have to keep going 600 times. And I don't actually have time for that, so I'll just quit this at this point. But it's as easy as that. If you need a really huge array, just change that number there up at the very first line of the program to however big you need it to be. All right, one other thing here. Those programs are starting to get a little inefficient when we test them, because as we pretend to be the users, we have to type in all this data. The whole point to arrays is that there are a whole bunch of variables and they store a whole lot of data. So now we're starting to spend more time just when we test it, typing in the test data. Here's another option. You can initialize an array to begin with, and it's going to look like this. Okay, so you're going to declare an array, and in the exact same line, you can write down equals, curly braces, and the stuff that you want the array to start with when the program starts up. So that is called an initialization list. This bit here in curly braces with a bunch of things separated by commas, that's an initialization list. You should know that phrase. And what that is doing is it's supplying starting values for an array at declaration. And we've said this many times before. If you make a variable and you don't initialize it, it starts up with random garbage. Same thing for an array. We've seen that in the examples already. So if you don't want your array to just be holding random garbage to begin with, you can do this, and then when the program starts up, it is holding these values in the same order instead. So that prevents uninitialized data, which is good. This will probably give us a little bit more efficiency when we test our programs. We can just use this instead of retyping the data every time we test it. This will probably show up in a lot of the examples in labs going forward, so this is kind of a nice tool here. Now, couple of ways that there might be an interaction in the size of the array declaration versus the size of the initialization list, because those actually might be different numbers. The easiest thing is when you declare the array to put a size inside the square brackets like we've seen before, and to make the initialization list the exact same number of things. Hopefully that's pretty obvious what happens with that. But what if those numbers aren't exactly the same thing? Here's some options. One, you can actually just leave the square brackets blank. Notice that I just left them blank here with no size. You can do that and that will actually compile. And what that is called, that's called implicit sizing. You're not giving the array an explicit size you actually wrote down. What it's going to do is it's actually just going to count how many things there are in the curly braces, and C++ will make an array of that size. Okay, so you, the programmer, don't have to count it up, don't have to give a size. Once again, the computer will just figure that out by counting how many things are in the initialization list. Okay, so that's one option. Just leave the square brackets blank and it's going to look at the list here. Okay, hopefully that makes sense. The other thing you can do is you can use partial initialization. So let's say you do give a size in the square brackets. You can still do that. You give an initialization list, but the initialization list doesn't have the same number of things. Specifically, it's got less things in the size. That'll also compile. And let's say you just give it 3 things, then the first 3 things in your array will be the 3 things in the initialization list. And again, that's the end of the list. And then all the other things in your array will be initialized to 0. Or blank characters or blank strings, if that's what you've got for the type. They'll all be initialized to zeros. So as soon as you put down an initialization list, you will not have any uninitialized data. It'll always be something known, starting with the stuff from the list, and if you need more stuff, a whole bunch of zeros after that. So there's a couple different ways that could possibly interact. Again, C++ is giving the programmer some flexibility about what they want to see there. So kind of keep that in mind. And here's an example of an initialization list. This is program 7.7 out of the book. This program initializes a string array. So as usual, make a named constant to hang on to the size of your arrays, what we normally do. So a constant integer called size set to 9. And this here, in this example, it's an array holding a whole bunch of strings. So the type is string, the C++ string object class there. The name of the array is planets. So apparently this is holding the names of all the different planets in the solar system. We are explicitly, in this case, giving the size of the array, namely 9. And here comes the initialization list. And you notice that this is so long, they had to break it up on separate lines. You can totally do that. We've done that before. So a very, very long initialization list. And the items in the list are actually strings, string literals and double quotes. And you can see there are 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And then they also threw in Pluto there, which used to be considered a planet and technically isn't anymore. But there's 9 things there. Great. And then just to do something with it, this program gets down to line 15, 16, and it's going to print out all of those planetary names, again with a for loop, starting at 0, going less than the size, and it's printing out planets subscript count. And once again, that for loop winds up printing every single one of those names to the screen. Awesome. So hopefully that's a little technique there that'll save us some testing time in the future. Again, the user does not have to type in all this data. It's already in the array when the program starts up. So that's a nice technique. Okay, so at this point, I think that's a pretty good introduction to arrays, right? It really just takes one single line of code to make as many variables as you want. You can make integer arrays, you can make string arrays, you can make float arrays, whatever you need. So my students and I will probably get together for an initial lab here, this lab here, in which I would ask people to write a program from scratch that uses an array. And this asks my students to write a program that creates an array of 5 strings, a little bit like that example we just saw, and then using a loop, get user input for the names of that many friends from the user, maybe Alice, Bob, Kathy, Dennis, Ernie, something like that. And then for the output part, print messages that say hello to each of the given friends. So hello, Alice, and hello, Bob, and hello, Kathy, and so on and so forth. All right, so I think that right there, hopefully it's not too complicated, but it's a pretty good introduction to getting accustomed to making a named constant for the size. We should probably do that. declaring the array. You want as much practice as that as possible. And then using for loops, which is the normal way that you process arrays in both input and processing and output. Probably in all of the programs that we ever write from now on are all going to use arrays. That's really the interesting thing about programming, is to very efficiently and conveniently handle large amounts of data, larger amounts of data than a human being could possibly deal with in their head. So probably all the programs we ever do from now on will be using arrays. And if you need to, you really want to practice declaring and creating arrays, writing these for loops to process them. That needs to be very familiar to you, very comfortable and very convenient, because that is going to be in all of our programs for the rest of our C++ course, as a matter of fact. So I think this lab here is a good place to start. All right, so that's the beginning of arrays. Obviously, there's a lot more to the story than that. Things that are interesting that you want to do with arrays. So when we come back next time, the next video, we're going to be looking at different techniques for processing arrays, like computing statistics on them, finding the total in an array, finding the average, finding the minimum, finding the maximum, things like that. And then also, of course, we don't want to forget, we need to make our programs modular, separated into separate functions. So if there's a task like any one of those things, there should be a separate function that just does that one single job. And if it needs data from an array, you're going to have to pass it in as parameters. So we'll see how to do both of those things in the next video, and I'll see you for that.